All right, so I'd like to make this little video for you to talk about degrees and radians, which are two different ways to measure angles. And radians seem a bit strange at first, but the more you deal with them, the more sense they make and the more useful they become, especially in later mathematics classes. Before we talk about radians, though, let's just kind of review what we know about degrees. Well, what we know about degrees, of course, is if you were to have, an angle that goes around an entire circle, we know that's 360 degrees. And there's some different theories as to where that number came from, but it is an arbitrary number. Some people think, okay, well, the Babylonians had a base 60 system, I believe. So, we have a base 10, but I think they had a base 60 system. So if you think about, maybe taking a circle and not sure why that keeps doing that, but if you have a circle and then you cut it up into some different portions, like, maybe kind of equilateral triangles of sorts, that would look like that. Each of these would be 60 degrees, and that makes 360 degrees. And so that kind of makes sense. But also, if you think about the days of the year, we have 365, but 360 is fairly common. So maybe astronomers are looking and say, okay, I'm noticing that the rotation of the sky is changing by 360th ish, I guess, per day. And so maybe relating that to the whole year and saying, well, it makes sense that there'd be about 360. And it's also a nice number because it's divisible by a lot of things. 360, we can divide it by 2, we can divide it by 4, we can divide it by 3, we can divide it by 6. There's lots of things that we can divide it by. And so if we're trying to describe different portions of a circle, it becomes very useful. And of course, we know things like a straight angle would be 180 degrees, or a right angle, which is a quarter circle, would be 90 degrees, and half of that would be 45 degrees. And we've got some nice triangles that add up to 180 degrees, where this is 60 degrees and 30 degrees. So there are some nice uses for degrees, and they can be useful. But in certain problems, it's much better to use radians. So let's talk about what a radian is. So radians. So let's talk about what a radian is. Now you'll notice that this word is very similar to radius. So there's a relationship there. Okay, so let's take a circle and let's draw the radius here and call it r. Now if we take that length of r, and let me see if I can change my color here, and we start at the end of that radius and we lay out the length of that radius on the circle. The angle that is created there is 1 radian. So in other words, we kind of formally define this as 1 radian is the angle, we call it subtended by an arc of length 1 radius, essentially. Okay, so that might not be the perfect definition, but it gets to essentially what we want to know. So you'd say, well, what if the circle changes size? Like, what if I have, like, a bigger circle like this? Okay, well, but that's going to mean my radius is going to be bigger. And again, if I take the length of that radius and I lay it out along my circle, I'm estimating here, but let's say it's about that long. And I look at the angle created by that, it's still the same angle. This angle right here is the same as this angle right here. So it's almost like an equilateral triangle, but not quite because of the curve here, right? This is curved. So this 1 radian is not equal to 60 degrees, but it's sort of close to 60 degrees, which we'll see. So it doesn't equal 60 degrees, but it's not going to be too far off. It's going to be a little bit less. Okay, so this basically allows us to find some patterns between degrees and radians. So 1 radian is the angle subtended by an arc of length 1 radius. Okay, well, let's think very quickly here about a full circle. So if we have a full circle like this, let's think about how many radii actually go around the circle. Okay, well, there's, 1 radius, and here's another radius. Here's another radius. We're almost halfway around now. Another one here. Another one here. Another one right here. Almost all the way around now. And then there's a little bit left. So what I've kind of shown is that if you lay, your radii around the circle, you should get 1, 2, 3, 4, 5, 6, and a bit more. So essentially what that's showing us is that the circumference of a circle is 6 radii plus a bit more. Well, you may be thinking, wait a second. I know how to find the circumference of a circle if I know the radius, right? The circumference of a circle, if I know the radius, is just 2 pi radii. And that actually tracks with what we've drawn here, because 2 pi is about equal to 6.28. So we can see that 6 plus a bit more is actually exactly, well, it's not exactly, but it's closer to 6.28 radii. That's how many radii it takes to get around a circle. Of course, it's not exactly 6.28 because pi is not exactly 3.14, but it's a little bit more. Well, what that actually tells us is if the circumference is 2 pi r, which it is, then that means there is 1 radian, because that is the angle subtended by 1 radius, 2 radians, 3 radians, 4 radians, 5 radians, 6 radians, and a little bit more to get all the way around the circle. Exactly, there are 2 pi radians for 1 full rotation. That's the important thing there. And again, why is that? That's because 1 radian is the angle created by an arc length that is equal to 1 radius. But to get all the way around the circle, there are 2 pi radii, which is a little bit more than 6, but it's exactly 2 pi radii. So if 1 radian is equal to 1 radius, then 2 pi radian is equal to 2 pi radians, or radii rather, around the circle. So what that tells us is that 2 pi radians is equal to 360 degrees, because we know that 360 degrees is all the way around the circle. Now, if I divide both sides of this equation by 2, I can also say that pi radians is equal to 180 degrees. And this is going to be a very important thing for us here, that pi radians is 180 degrees. And so I can also, if I want to know what, say, 1 radian is in degrees, I could divide both sides of this equation by pi. And now I have 1 radian is equal to 180 over pi degrees. Or if instead I wanted to know how many radians there are in 1 degree, I could divide both sides by 180. And I would see that pi over 180 radians is equal to 1 degree. Need to erase my little degree symbol here, but otherwise that is correct. Okay, so this all will probably feel a little bit confusing to some of us, and that's okay. But I want to remind you that what we've talked about so far is, first of all, degrees. That degrees are a bit arbitrary, and they can be useful, but in later mathematics, we need a different system. 360 degrees to the full circle. We talked about radians. 1 radian is the angle subtended by an arc of length 1 radius, the central angle there. And so you can see 1 radian is fairly close to 60 degrees. And then for the whole circle, since the circumference is 2 pi radii, then we know that there are 2 pi radians to get around an entire circle. So if 2 pi radians is 360 degrees, that allows us to have pi radians being 180 degrees, and allows us to convert between the two, essentially. And we're going to see some examples of that. So coming down here, I'm just going to draw some things out just to give us a sense for how many radians, different angles that we're familiar with are. So for instance, if I were to go all the way around the circle, that would be 2 pi radians. And we're not going to write an approximation and say, oh, it's about 6.28 radians. We're just going to say 2 pi radians. Halfway around a circle, that would be pi radians, right? And you saw in our drawing up here that when I drew the radiuses out, or the radii out, when I got to 3, it should have been a little bit less than 180 degrees. So 3.14, 159, etc., would be exactly 180 degrees, or pi radians. That means also that a 90-degree angle, that's half of pi, so that would be pi halves radians, or pi over 2 radians. And if I cut that in half again and did, 45 degrees, that would be pi over 4 radians. So again, this might seem confusing at first, but eventually it will become pretty straightforward. But let's see some problems where we convert from degrees to radians and vice versa. So the thing that's going to be very useful to us is that pi radians and 180 degrees are the same thing. So since that's the case, this fraction is equal to 1. And we can use it as a unit conversion. We also know that 180 degrees divided by pi radians is also equal to 1. So we can multiply it. It's very similar to when you've converted things from, say, 1 foot to 12 inches, or 12 inches to 1 foot, right? These fractions are equal to 1. Or maybe you did 2.54 centimeters is equal to 1 inch, or 1 inch is equal to 2.54 centimeters. These fractions are equal to 1, and they allow us to convert how we measure things. So we are going to be doing something similar with angles. So let's say we want to convert to radians. And we will start with, let's say, 60 degrees. And maybe let's try 135 degrees and 270 degrees. Okay, so to convert from degrees to radians, we are going to multiply by pi over 180. So if we take 60 degrees and we multiply by pi radians over 180 degrees, you can see that our degrees are going to divide out, and we end up with 60 pi over 180 radians. Now we'd like to simplify that. So we will now simplify 60 over 80 is just 1 over 3. So that ends up being pi over 3 radians. Now pi over 3, remember, is, let's see, why has my marker stopped working? It's, uh-oh. Why is my marker not working? I think I accidentally made it clear. A little bigger than 1. Which makes sense, right? Because pi over 3 would be 3.14159, etc. over 3. So it's a little bit bigger than 1. And remember, we said a radian would be a little bit less than 60 degrees. So pi thirds radians, it makes sense that it would be pi over 3 radians. Or sorry, that it would be 60 degrees. Let's try with 135. We'll multiply by pi over 180 degrees. We end up with 135 pi over 180. And then we just need to simplify. Well, those are both divisible by 5. So I believe if we divide 135 by 5 and 180 divided by 5, let's see, what are we going to end up with? I got to do this in my head. 135 divided by 5 is 27. 180 divided by 5 is 36. Those are both divisible by 9. So we can go ahead and write that as 3 pi over 4. 3/4 of a pi radians. That's the same measure as 135 degrees, but now in radians. Makes sense that it should be less than pi, because remember, pi radians is equal to 180 degrees. So 3/4 of a pi radian should be less than 180 degrees, which it is. 270, on the other hand, should be more than pi radians. So again, we'll multiply 270 times pi divided by 180. We get 27 pi over 18. Those are both divisible by 9. 3 pi halves radians. Okay, so when you're converting from degrees to radians, you're going to multiply by pi radians over 180 degrees. Just like if you had feet and you wanted to convert to inches, you'd multiply by 12 inches over 1 foot, right? And you would get your answer in inches. Now let's suppose instead we want to convert from radians to degrees. So if we want to convert from radians to degrees, let's say we have pi radians. It's a very easy one. Or maybe we have 2 pi thirds radians. Usually radians will come in terms of pi. Or maybe we have 5 pi sixths radians. Or maybe we have pi fourths radians, and we want to convert it to degrees. So if we want to convert it to degrees, we're going to multiply by 180 degrees over pi radians. So let's take pi and multiply by 180 over pi. Well, of course, the pi's are going to divide out, and we'll end up with 180 degrees. We already knew that pi radians was 180 degrees. 2 pi thirds. We're going to multiply by 180 degrees divided by pi radians. Our pi's will divide out in this case, and now we'll get 2 times 180 divided by 3 degrees. I'm going to decide to divide by 3 first, so 180 divided by 3 is 60, times 2 is 120 degrees. 5 pi 6 radians. I'm going to take 5 pi 6 and multiply by 180 over pi. Pi's will divide out. I get 5 times 180 divided by 6. Divide by 6 first, and I have 5 times 30, which is 150 degrees. Makes sense, because that's less than a full pi, and pi is 180 degrees. Pi fourths radians. So I can either think of this as, well, I know pi is 180, so a quarter pi should be a fourth of 180, which is 45. But I can also take pi fourths and multiply by 180 over pi. Pi's will divide out again, and I get 180 divided by 4. I don't know why that's so messy. So 180 degrees divided by 4, which is 45 degrees. Okay, and eventually there are going to be some angles that you'll just kind of have memorized in terms of, what they are in degrees and what they are in radians. So I'll just mention some of those. So of course, 0 degrees is 0 radians. 30 degrees is going to end up being pi over 6 radians. 45 degrees is going to end up being pi over 4 radians. 60 degrees is going to be pi over 3 radians. 90 degrees, pi over 2 radians. And there are some others, but for now, maybe I will just put in 180 degrees, which is pi radians, and 360 degrees, which is 2 pi radians. So these are all going to kind of become fairly familiar, especially when you take pre-calculus. So the most important thing is that if you want to convert to radians, you're going to end up multiplying by pi radians over 180 degrees. And if you want to convert to degrees, you are going to be multiplying by 180 degrees divided by pi radians. So those are your conversions between the two.